In this video, we're going to explore the concept of the discriminant. Now, the discriminant is useful, particularly if you're not able to graph something, to figure out how many roots a quadratic equation has. So here I have three quadratic equations, and we're going to investigate the discriminant of each of them. There are three possibilities. So we'll see in the first one here, if I put that in, and I go ahead and I graph it, we can see that it looks like the parabola is touching only in one spot. So that would be one double root. Let's go ahead and turn this off, and let's look at the next one. So if we graph the second one, we wait for it to drop down, we will see that it's not touching the parabola, the x-axis at all, which means that we have exactly two imaginary roots. And if we look at our third one, so I'm going to come down and I'm going to turn off this equation and turn this one on, we'll see that it exactly graphs two roots, or two zeros of our function. Okay, so those are the three possibilities that we have when working with a quadratic equation and trying to find the roots. So sometimes we just want to know how many roots as opposed to the exact root. So let's go ahead and we're going to write down the first function that we have, which is this 2x squared minus 16x plus 32. Okay, so we're just going to go ahead and we're going to sketch what that looks like. So I'm just going to go ahead and I'm going to draw my parabola here. And we know from looking at the calculator that it touches the x-axis exactly in one spot. So I'm going to put my x-axis there, and I'm going to put my y-axis there. I don't really care where it is. This is just a sketch, so I'm not being perfect about anything. So if we look at number of roots, we have what's called a double root. Double root right here. Okay? And we can actually investigate and see what that is. So what we're going to do though is let's talk about the discriminant. So the discriminant comes from the quadratic formula. So what is the quadratic formula? The quadratic formula is where x equals negative b plus or minus the square root b squared minus 4ac. That entire thing is over 2a. So that's my quadratic formula. So where is the discriminant? The discriminant lives underneath the radical. It does not include the radical, it's just what's underneath the radical. So that discriminant there is b squared minus 4ac. But we're going to look at it with the entire quadratic formula, because that will help it make sense to you a little bit more. So the first thing we need to do is we need to find out our a, our b, and our c. So let's go ahead and write that down. So a is 2, b is negative 16, and c is 32. I just get in the habit of writing down little things like this because it makes it easier for me to substitute things in. So now I'm going to go to the quadratic formula and I'm going to substitute in those values. So I have x is equal to negative b. Notice I put my b in parentheses. This negative is in front of the b. This negative is the b. So it's a negative negative 16 plus or minus the square root of negative 16 squared. Notice I put the negative 16 in parentheses, minus 4ac. Move this over a little bit more so we can see it. And that entire thing is divided by 2 times a, which is 2. Okay. So what I want to do in my calculator before I do anything else is I'm going to calculate what is underneath the radical. So I'm not going to include the radical. So I'm going to go to my calculator, and in my calculator I'm going to put in parentheses negative 16 squared minus 4, and my parentheses acts as multipliers, so I don't need to use the multiplication sign. So notice there is no radical there. I get 0, as should be expected. So let's see what this looks like. So that gives me then x equals, well, a negative and negative is a positive, 16, plus or minus the square root of my radical, my discriminant, which was 0. So if I go to simplify this, I simply get x is equal to 16 divided by 4, which is the same as 4. So x is 4, y is 0. So my root is at 4, 0. Okay? So notice when I got 0 under the radical, I simply got one double root. And the reason it's a double root, because if you remember from before, let's look up here. This exponent right here, my highest exponent, tells me that I must have 2 roots. And in fact, when we go to figure this out, if this here is where x is 4, then that would mean that x is 4. So we must have factors such as x minus 4 times x minus 4. If we were going to go ahead and multiply this out, let's go ahead and do that just for review. X minus 4, x minus 4. I get x squared minus 4x minus 4x plus 16. And that gives me x squared minus 8x plus 16. Okay? So this here, if I were to factor this, gives me the factors x minus 4 times x minus 4. But what was our original? Our original was 2x squared minus 16x plus 32. So you can see that I have a factor of 2. So this has been increased by 2 because 2 times x squared is 2x squared. 2 times negative 8x is negative 16x. And 2 times 16 is 32. So these, if I were to factor, would be 2 times x minus 4 times x minus 4. I have a double root right here. Okay, so that was just a little bit of review. I promise I won't quite go in as much detail in the next one. So we're going to look at our next function that we had here, which is 2x squared minus 16x plus 34. So let's go ahead and write that down, and we're going to go ahead and we're going to sketch it. So what do I have? I have my function y equals 2x squared minus 16x plus 34. Okay, so let's just go ahead and we're going to see what that looks like in our graph. So I'm going to turn this one off, turn my next one on. Oops, didn't turn that off. Didn't turn that off either. Okay, so now I'm going to graph it. And as soon as it graphs, we'll see it does not touch the x-axis. So I'm going to go ahead and I'm going to sketch this. So I'm going to have my x-axis, and I'm going to have my y-axis, and I'm just going to sketch it. Because I'm sketching it, it means I don't really care about the points, I'm just getting a concept idea. So as we can see here, there are no real roots, but they're only imaginary roots. So because it's not touching, I have imaginary roots. In fact, I have exactly 2 imaginary roots. And I'm going to prove that to you right now using the quadratic formula. So let's write down our A, our B, and our C. So my A is 2, my B is -16, and my C is 34. Okay, so let's go ahead and put it into the quadratic formula. So I have x is equal to -b plus or minus the square root of -16 all squared minus 4 times 2 times c all over 2 times a. Okay, so again, I'm just going to look at the discriminant, and the discriminant is what's underneath that radical. So again, I'm going to just do what's underneath the radical. I'm going to go to my regular screen. We can see this was from the last discriminant that I did. So this is -16 squared minus 4 times 2 times 34. And you see I get -16. Well, let's see what that means. So that means underneath the radical here, I have -16. Okay, that's very important. So I have x is equal to, well, that's going to be +16 plus or minus 4. So I have to simplify the square root of -16. When I simplify the square root of -16, I get x is equal to 16 plus or minus 4i all over 4. And that simplifies to 16 divided by 4, which is 4, plus or minus 4i divided by 4 is just I. So what does that mean? That means I could have x equals 4 plus I, or x equals 4 minus I. So I have 2 imaginary roots. Okay, I have 2 imaginary roots. And we could see right here that my discriminant is negative. So let's go ahead and highlight that. Because a discriminant, when it's negative, so there we have negative. And so a negative discriminant will give me 2 imaginary roots. Where up here, if my discriminant, which I didn't mark this, is 0, so right here my discriminant is 0, which means 1 double root. Okay, so there's one more that we're going to look at, and then we're going to make like a little table to help us remember this. So I'm going to go ahead and turn my paper over, and we're going to work on the other side. So the next one that I have is 2x squared. So let's write this down. 2x squared minus 16x plus 30. Okay, so let's go ahead and graph it. And if you recall, this one here actually crosses our x-axis in 2 points. So we have a root here at 3 and a root at 5. Okay, so let's go ahead and we're going to put in our y-axis and our x-axis. And again, I'm just sketching, so I really don't care what it looks like. I'm just trying to conceptually get an idea. So I'm just going to draw that in there. And then notice I have 2 real roots. Okay, I showed you in the calculator we're going to get 2 real roots. So now I'm going to show you using the discriminant how we figure out if the root is 2 real or not. So let's go ahead and do what we did before. Our A is 2, our B is negative 16, and our C is 30. Okay? So let's go ahead and let's use our quadratic formula. So, oops, don't want to use red. So we have x is equal to negative b, which is negative 16, plus or minus the square root of negative 16 squared minus 4 times 2 times 30, all divided by 2 times 2. So we're going to go ahead and we're going to look at just the discriminant, which is just this yellow part here. Okay, so let's look in our calculator and let's put that one in. This is our last one. Negative 16 squared minus 4 times 2 times 30. Okay, and we get positive 16 that time. So that means I have x equals a negative times a negative is a positive, so that's 16, plus or minus the square root of positive 16 all over 4. Okay, so what does that mean? Let's simplify this. So this is x is equal to 16 plus or minus 4 all over 4. So we've got, again, we've got 2 roots that we can take. So let's go ahead and do this. So that's 16 plus 4, which is 20, divided by 4. And then we have 16 minus 4, which is 12, divided by 4. So 20 divided by 4 is 5. 12 divided by 4 is 3. So our roots are 5, 0, and 3, 0. And that's exactly what I showed you they were on the calculator. So notice that our discriminant, let's look up here at 16, our discriminant is positive. So here our discriminant is positive, which means we get 2 real roots. Okay? 2 real roots. Okay, so let's just kind of sum this up a little bit. So we're going to sum it up with what we looked at before. So let's go ahead and we're going to write out all of the quadratics. So what did we have? We had 16 plus or minus the square root of 0, and then, all over 4. And then the other one we had was 16 plus or minus the square root of negative 16 all over 4. And then we had 16 plus or minus the square root of 16 all over 4. Okay? So those were the three that we had come up with. So when we think about what this is, so let's just look at the discriminant. So here, 0 is the discriminant. Here, negative 16 is the discriminant. And here, positive 16 is the discriminant. So what this means is, if the discriminant is 0, then we have one double root. Okay? If the discriminant is negative, which it was in this case, then we have two imaginary roots. And last but not least, if the discriminant is positive, we have exactly two real roots. Okay? So this is a concept that you need to be familiar about because it's a question that will come up from time to time. I'm going to back out my screen a little bit. So it comes something that you need to know, because it might be given a question on your SOL such as the discriminant is 0. How many roots does it have? Are they real or are they imaginary? If the discriminant is negative, they may not even give you a number. So you need to understand this concept, if nothing more, that you know the discriminant is underneath that square root, and you can try to think it through that way. So that's the value of the discriminant. It tells you how many real or imaginary. The last thing I want to do here before we close is let's go ahead and I'm going to draw a quadratic here, and I'm going to put in the x-axis, and I'm going to circle here. That's my root. I have only one. Okay, and then on this one here, I'm going to draw in my parabola, and then I'm going to put in my x-axis. My x-axis is down here, and it's not touching, so my roots are imaginary. And on this one here, I'm going to draw my parabola, and then I'm going to draw on my x-axis. And so here we see that we have two real roots.